Hello everyone, my name is Vikas Napure. Today I will be discussing about IoT based home automation system which are built on the Emertxe IoT internship. First we will see the PPT and then I will be share demonstration of project. The content of project and the topic we have learned in the internship is C programming IoT, embedded things, microcontroller, project overview, objective, design element, simulation of project and last conclusion. I am go to the next slide. C programming. C is a powerful general purpose programming language which can be used to develop a software like operating system, database, compilers and so on. C programming is created by the Intrenship in 1972 at Bell Laboratories. And the third one is syntax that is generally used in the C programming language. And this is a topic that we have learned in the C language data types. And in the data types we know that there are four basically data types: character, int, float, double, modifier, qualifier, conditional and loops, operator, array is a collection of similar data types, pointers, string, function. In the function we know that how to declare a function and store a class and preprocessor. And next set, what is IoT? IoT is a basically the Internet of Things that describes a network of physical objects that are embedded with a sensor, software and other technologies for the purpose of connecting, exchanging data with other devices and the system over the internet. Some of the example of IoT that are embedded with the electronic software and sensor is smart refrigerator, smart air conditioners, light in household, connected security systems, or even the person with heart monitor or in the automobile. And this IoT system can be used in the build and home automation systems, environment monitoring, smart transportation, medical and healthcare system, and the smart manufacturing companies. Next is embedded system. Embedded system is one of the computer hardware with software embedded. We can also say that the embedded system as the microcontroller based system that doesn't look like a computer. And we can also say that the embedded system is a combination of computer hardware and software that perhaps the additional mechanical and the other parts designed to perform a dedicated function. In the some cases, embedded systems are the part of the larger system or the product, as in case of the anti-lock braking system in the car. The application of embedded system is as the street light control, detecting the rash driving on highways, traffic signal control system, embedded system for the home automation systems, and some of the example of embedded system is used in the GPS system, fitness tracker, medical devices, automotive systems, transit and fare collections, and ATMs. Then we have learned about the part of our components of the embedded system. Embedded system basically content of the three parts, that is the system on chip, microcontroller, microprocessor and memory elements. Microcontroller contains unlock to digital converter and digital tornado converter, blocks timers and counter pulse with modulations, processor, memory and input output ports. And we have learned also the microprocessor and microcontroller systems and its advantages and properties and so on. In the memory element we have learned the memory type, that is RAM, ROM and it types also. Let's go to the next slide, that is overview of a project. Project provides the IoT based home automation solution using the Arduino UNO board that control the home lights, temperature, water tank in inflow and outflow. Using the Blink IoT mobile application, we can control the devices remotely. Next is why home automation. Generally, people do not stay at the home. This brings the problem of home application that is not monitored. So the problem The solution of this problem come out to be home automation. The home automation enables a person to control the most of the devices remotely, such as the volume of the water present in the water tank, garden lights, and the temperature of home. So here we use Arduino. Arduino UNO is a microcontroller board based on Atmega D28P. It has a 14 digital input-output pins, 6 analogs, 10 pins, and 60 megahertz ceramic resistor and USB connections, power jacks, ICSP header, and the reset button. Uh, it can be programmed using the different IDE. Arduino IDE in the US in the project Arduino IDE also supports the C and C++ language. Next is PixemLab. PixemLab is an open source real-time emulator of the development boards with the integrated MPLBX EVR GDB debugger. It also supports the some microcontrollers and similar microcontrollers. It has the integration with the Arduino IDE for the programming of the board microcontrollers. Next is LDR. LDR is a light dependent resistor that detects the lights falls upon it. The photoresistor is a light control variable resistor. The resistance of the photoresistor decreases with increasing incident light intensity. The LED lights are connected with the LDR with the help of ADC and ADC that converts the analog input by the LDR into the equivalent digital from which then converted later into the certain formula from 0 to 255 at the upper bound. Based on that we glue the LED. Next is garden light control. The properties of LDR sensor are applied to be accomplished with controlling the garden lights during the day of the outdoor light is maximum, so the LDR detects the light and the garden light it is turned off, whereas at the night outdoor light is very low, so the LDR sensor detects the light and the light is turned on. Next is temperature sensor. Temperature sensor recorded using the LM35 sensor which reads the analog value. The value can be converted into temperature that is calculated by the obtained value of the voltage. The sensor does not trimming the accuracy plus minus 0.5 degree Celsius room temperature to 1 degree Celsius over 50 degrees Celsius to 155 degrees Celsius the temperature range. The output provides the output voltage of NV 25 degrees Celsius. Next is water tank inlet and outlet value control. Volume of the water in the tank through the serial communication display it on the CLCD. Control the volume of the water in the tank by controlling inlet and outlet valve. Sending the commands through the serial communication and display the volume of the water in the tank on the CLCD and allows in the Blink IoT app. The tank refills itself when the outflow exceeds the threshold of the minimum value of the 2000 liter and it stops the filling when the tank is full at the 3000 liters and gives the notification to the Blink IoT app. And we have used the Blink IoT configuration in which we have learned how to create the new template, how to add the devices, how to select and add data stream, and how to create an icon and how to include the Blink library. So this is the screenshot of our project. Here the screen where we can see the current temperature and the volume of our water tank. We will also see the inlet valve and outlet valve are turned or off. And again we will also see the heater cooler are turned on or off. Then we will also see the demonstrator that I will show you the further video. This is the heater cooler system. Here we can here we can place our LED light, and this is our LDR sensor currently that is depreciated in the dark, so the light is turned on. If it is in the sunlight, the light will be automatically get turned off. Next is the screenshot of the blink app. Here we have a two types. First type is detecting the cooler and heater button, which can be control the room temperature. If you clearly see that the notification which can be saying the temperature is greater than 35 degrees Celsius, so turning off the heater like the previously discussed. And then again the screenshot of the tab 1, but with the different notification. It says that the water level is less than 2000 in flow. That enables again. We have discussed the point previously. The tab 2, we can see the inlet valve and the outlet valve button in the control of the water tank, and here we can see the current value of the water tank. Next is conclusion of our project. We provide a person who will not stay at the home can be remotely manage their own application and other devices. The home automation project is emulated using the Blink IoT application and the Pixim lamp simulator, where the LED temperature systems and the serial tank mimic in the real-time lightings, heater, air conditioner and water tanks. Using the Blink IoT application, the customer may automate their home by the controlling various gadgets as desired. Thank you everyone for watching the video. So this is the whole code of the project, and this is the Pixim lab. Here we can the screen like we saw in the screenshot. This is the water tank in which currently full. Now I will be controlling it with my blank app. It just a screen my mobile. So how here we can see the blink app. It turn on the cooler. You can see here we see the cooler is switch on. Now if turn on the heater is on. The cooler is off, and we can see the temperature is rising. Now as soon as the temperature rises about 35 degrees Celsius, our heater gets off and we will receive the notification like will talk. Now we will function the tab the volume system. Our tank is currently full, so I will be switch on the output valve. So the volume is decreasing like you can see. Now as soon as the volume decreases below 2000, we will see in the tab 1 we will receive the notification that is the water level it increases above the 2000. You can see the water inflow is enabled. We will also see this the LED functioning. Here is the darkness. It is depreciating there is a lot of darkness, so the LED is on. Now if we just decreasing this bar, it is depreciating there will be the sunlight, and therefore the LED is turned off. So thank you so much for watching the video, and this is about the all project.